Hi everyone, this is BitcoinKernel Club. This is the first session of this club, and I'm Yuvik, and I'm here to talk about BitcoinKernel, the project that I have been working on, which aims to extract or basically modularize the Bitcoin Core consensus engine. So when we download and run Bitcoin Core, it is nicely packaged into a single bundle, a single application. However, those of us who have studied Bitcoin Core or other piece of applications might know that Bitcoin Core, just like most of the applications, is a collection of subsystem and which includes GUI, P2P wallet, mempool, RPCs, and consensus engine as well. So, so the consensus engine, which we will talk about, is also known as the heart of Bitcoin. And why did I refer the consensus engine as the heart of it all? Because it keeps tracks of all the blocks and it manages the UTXO set as well. And if you look into the right folder of your the Bitcoin node, then you might have all these files, the blocks which contains all the blocks files, basically the blockchain that has been downloaded from your peers that you are connected, and the chain state which contains all the UTXOs. And and consensus engine is also it defines what is valid and what's not, and it is basically the arbiter of truth, what defines what Bitcoin is or what Bitcoin blockchain is. So since the consensus defines what is valid, and it is then crucially important in a distributed system like Bitcoin, and to make sure that the consensus engine of all the participants, these are all the participants, and they all agree with each other. If that doesn't happen, for example, if these four people running the Bitcoin node or basically Bitcoin consensus engine, then they might not be in sync with other nodes who are running the correct consensus engine. So that is one of the problem, and this is the key goal that Bitcoin kernel solves. And we can see that happening as well. So Bitcoin Core has their own implementation of consensus engine, and there are other implementations such as BTCD, libbitcoin, and we have seen that happening. BTCD, like in version 0.24.2 or version 24.2, had a consensus bug. So if someone running this version, they are actually not in sync with the Bitcoin network. And same we have seen with libbitcoin as well. Libbitcoin is another Bitcoin client that runs their own consensus engine. So that's the problem. So let's get back to the subsystem of the Bitcoin core. So the main problem in Bitcoin core is the code entanglement. Why there is not a single consensus engine? Why the BTCD or libbitcoin, why they didn't use the consensus engine of Bitcoin core? Because Satoshi wrote that the Bitcoin core consensus engine, right? So the major problem was when he wrote the code, it was entangled. Entangled means there was no set of rules or set of uh, guidelines what is the consensus engine, or basically what is the code that is the consensus engine and what's not. There was the consensus engine was in fact in P2P, was in GUI, was in mempool, RPC wallet, everything. This was the code entanglement problem, and that's why BTCD, they implemented their own consensus engine by looking at the Bitcoin core's uh, validation logic or consensus engine. Okay, and extracting out the consensus engine from the other parts of the Bitcoin core is one of the key goals of this project. So that we'll have a clear sense of what is the consensus engine and what's not, because that's all we require. So if you have the consensus engine and you want to play with the Bitcoin network, you have some projects, you want to experiment with that, then you just need the consensus engine, and then you can just plug the project with the consensus engine, and you are good to go. You are staying in the Bitcoin network. You won't get forked out or eliminated from the Bitcoin network. That's the key goal of this Bitcoin kernel. Now, I'll also want to discuss that I've already discussed experimenters. So if someone wants to experiment with Bitcoin, and they have an idea, for example, coin swap, or for example silent payments and coin join as well, so they can use this Bitcoin kernel, basically the consensus engine, and then they can experiment with. Or for example, if someone wants to implement a full Bitcoin node in JavaScript, we don't have in JavaScript. So if someone wants to implement in JavaScript, they can just use the consensus engine, or basically Bitcoin kernel, which is just the consensus engine, and they can implement their own P2P, own GUI, own wallet, and something like that, own mempool as well. And also, they may also want to get rid of the mempool. There are some projects that don't require mempool. They want to get rid of that, and they want to like also replace the P2P or the peer-to-peer system of Bitcoin Core to something P3P or something like that, and also replace the RPCs with the gRPCs, which is more faster than the RPC or the traditional RPC, and then also replace the graphical user interface with something like TUI, terminal user interface, and then a wallet is a different kind of rabbit hole. And also we have especially in the Bitcoin, we have a Rust evangelism strike force team who uh, this was in Reddit. I just saw that there is always a group of people in Rust who wants to re-architect all parts of the product in Rust. So that's the Rust evangelism strike force team, and they may want to re-implement all the parts of the Bitcoin into something like this in Rust crates. So like a Rust const expert UI and Rust P2P, Rust Bitcoin wallet, Rust cap, and Rust Bitcoin mempool as well. So the challenges that these developers, or basically these experimenters, they actually face with three challenges. The first one is peer review. They can have their own set of you know like features. They want these features to be included in Bitcoin Core, because as far as I can know that the consensus engine of Bitcoin Core is being used by more than 95 to 98%. And the challenges that these developers or these experimenters face is with PR review. They can have their code included into the project, or basically Bitcoin Core, but Bitcoin Core, they just don't want to include too many features because they bloat the code base, and also it increases the a burden of reviewing the PR, and it may take a lot of time to be merged as well. Now what these developers do is they create the fork of Bitcoin Core or the project, and they implement their own feature, and then use that project. This is not a network fork, this is just the code base fork. Okay. And they may also implement the consensus engine. We have seen that BTCD has their own consensus engine. I mean, it follows the guidelines of Bitcoin, but there might be some language specific quirks, there might be some bugs in JavaScript or in Java or in Rust, and that might create the network split, or basically the project that they have built, they might not be in consensus with other nodes running the consensus engine. So that's the problem, or basically the challenges. And again, I've discussed extracting out this, or basically entangling this the code is one of the key goals of the Bitcoin kernel project as well. So there was a before getting into what Bitcoin kernel, is there was a prior effort back in 2010 that was Bitcoin consensus, and it I would say it was actually incomplete because it only supported script verification, and it didn't had any UTXO set management or basically block tree management, block validation. Block tree is just a collection of blocks, and block validation is just simply a single block validation. So Bitcoin kernel. So we don't want to build a perfect library or basically a perfect project from scratch. We just want to reuse the existing classes of Bitcoin core, okay, the C++ classes or something like that. And then we use that existing classes, and with that we'll create a reusable API, and then you can we'll just refine that API, and this is all done in incremental approach. So it's like we'll just create a basic API, and that has already been merged, and then after that, with that we'll have a reusable API so that everybody can use that API and then refine that API as per the needs. So this was the PR 30595, which introduced the C header API, and C was actually used. We thought of using C++, but the main feature of Bitcoin kernel, or basically use case of Bitcoin kernel, is that every project can use the consensus engine. So there might be projects who there are a lot of projects which are not using the C++ language as the first language in the project, but Rust as well, JavaScript or Java or something like that, but that might not be in C++. So if we have built the library or basically the API in C++, what happened is Rust has a good support with C++, but not JavaScript, and not Java, so not Kotlin. So C was used because every programming language has good support with the C language. So that's why C was used as the for the API part, not for the internal part, just for the API, like exposing the consensus engine to everybody. Just for that exposing part, C has been used. Now there are language bindings, and if you think why does the language bindings or the API has a support in other languages, because we have seen there are lots of projects in Rust, for example Utrexo or Floresta or Rust Bitcoin. So what they can do is they can just use these Rust bindings. This is the Rust binding that has been maintained by the charlatan, and they can just use these Rust bindings, and then they can use the consensus engine, and then they can do whatever they want, whatever their goals of the project are. Similarly, we have in Python as well, we have in Java, we have in Golang as well, and we have in JavaScript as well. It's not mentioned here, but there is one in JavaScript. So if you look at the real world use cases of the Bitcoin kernel, that is read-only kernel clients. Read-only kernel clients are basically the Bitcoin clients which doesn't require uh, the full Bitcoin core features. For example, they don't require RPC, they don't require mempool. They just need the consensus engine so that it can validate whether that whether the block or whether the transaction, whether that script is valid or not, whether its consensus valid or not. That's the main goal of these read-only kernel clients. And external indexers such as Silent Payments and CoinSwap, they might need the indexer for validating whether the transaction or whether that block is valid or not. And alternative clients, they don't require mempool. For example, Floresta, which is based on UTXO protocol, and Floresta, they don't, for the client nodes, they don't require mempool. And if they use the Bitcoin core, then they have to maintain full mempool. But if they don't, then they don't have to like you know require, they don't have to maintain the UTXO set. So they can use the Bitcoin kernel. It provides the consensus engine, that's all they require, and that will be easy for them as well. And for other clients as well, which is Swift Sync, this is also a hash based accumulator client, and Bitcoin J as well, or basically any wallets as well, like Sparrow or something like that. They can use this because all these wallets and SPP clients, they don't require the full node, so they can use just the Bitcoin kernel for the consensus engine part, and then they're good to go. And also personal projects, if you have any personal projects, and you can utilize this API for building the project for if it doesn't require mempool, then you can just use this library. So improvements, potential improvements that we will be looking, or basically will be seeing in the future. Sans IO version of the API, Sans IO, or basically IO less or input output less, means that in in embedded system or something like that, you can't have input outputs. So that is one of the problem. And for that, if you use the Bitcoin kernel API, then you don't have to do currently Bitcoin kernel needs input output, but in future we may have the version of the API that don't actually need input output. And next is isolated kernel repo, or basically consensus engine. So currently the API is merged in Bitcoin Core, in the Bitcoin Core project or repo. So you have to clone whole repo just for the consensus engine, or basically the API part. So that is a bit of headache. And in future we might have a isolated kernel which just contains the the consensus engine. It doesn't contain anything, so you'll just clone that kernel repo, and you will have all the consensus engine part. And if you think, if evicting the mempool policy, or basically pluggable policy, so mempool is basically the collection of all unspent transactions. So if there are unspent transactions, the mempool stores all the unspent transaction if you're running a full node. Okay, so what happens is mempool has a policy. So there might be some policy like you want to store this kind of transaction or not, you want to store this type of block, not blocks, but all the transaction, unspent transaction, if you want to store this UTXO or not. So that is a kind of policy. There are lots of policies. So the policies might differ from clients to client. For example, Bitcoin Core might have policy that only this this transaction will be stored if it pays this amount of fees, or BTCD might not store that transaction, or libbitcoin might not store that transaction. Okay, so that is the policies, all the mempool policies. So different clients or different users have different requirements for the policy. So in future we might have like a pluggable mempool policy. For example, you're running the Bitcoin kernel, you can plug in your own policy, or basically your code which contains all the policy. You can plug that policy and use that policy instead of the Bitcoin core policy. So we want to evict that as well, or basically plug your own policy, something like that. And also context minimal validation. So context here means, suppose you want to use the consensus engine, or basically the validation logic, all the validation logic of whether that block is valid or not, whether the transaction is valid or not, whether that script is valid or not. These are all the validation logic. So what is context validation and what is context minimal validation? It's that context validation is that you will require the whole blockchain. For example, a block might be valid if it if it agrees or if it satisfies all the consensus check. But there might be some check. For example, the block header, the block hash should be lower than the previous one. That's the one of the requirement. So for that you will need the previous block as well, okay, or the previous block header or hash, you will need that. So context means you'll need all the prerequisites for validating, for fully validating that block or fully validating the transaction. Similar goes for transaction. If you want to validate a transaction, then you will need the previous transaction, because you want to see whether that transaction is valid or not, so that you can validate this transaction. So currently we are not context minimal valid, we are not doing context minimal validation, but still there are some functions which you can do just for validating that whether this transaction passes the consensus checks or not. Okay, but there might be some checks which require context. So the current Bitcoin kernel is not context minimal, but in future we might have a context minimal validation as well. And this is the end of the presentation, but we'll look into the library basically. So if you go into the a bitcoin repo, and then if you go into source and then kernel, and then you can see we have a bitcoin kernel.h. This is actually the header file, or basically C header file, or C API header file. So this is actually what you need for, you know, to run all the consensus engine, or basically this is actually the doc, you can say, for the library. So if you see here, these are all the preprocessor directives. C has a lot of preprocessor directives, so we'll not go into that, but we can definitely go into this comment section. So the purpose of this header file is basically, you can see here, the header currently exposes an API for interacting with the parts of Bitcoin Core consensus code, and users can use this header file to validate blocks, and then iterate through the block index and read the block and undo data from disk. Undo data, if you're not familiar with undo data is basically, uh, suppose a block has been mined, and it might contain all the transaction that has been included in the block, but the previous block might not have the transaction that has been included in this block. So the undo data might contain all the transaction that was not included in that block. Okay, that was not included, or basically the UTXO set. That's the undo data. And why it's required? It's required when there is a chain split or chain reorganization. Whenever there is a, for example, two miners are competing for a block, and suppose both miners mined a block at the same time, then we'll just follow the most cumulative proof of work. So for example, then again after that, two blocks has been mined more, and there are two chains, and suppose both chains have, suppose one of the chain mined the block faster than the other chain. So what happens is that chain is followed, but the block that was that didn't contain the most cumulative proof of work is being staled. So what happens is, when that block was mined, when that staled, the block was mined, it has some undo data. So what undo data contains is all the transaction that has been mined, or basically all the transaction that wasn't mined, all the UTXO set. So what happens is that block is invalidated. So whatever transactions were mined, that comes into the mempool. So how does the mempool know, or basically the node knows whether that transaction was mined or not? Through undo data. So that's how the undo data is required. That's the reason why undo data is required. And users can validate blocks, iterate through the block index, read block, undo data from disk, and validate scripts. So if you see here block data from disk, so that means you need to have the block data, or basically context, all the blockchain onto your disk. So that's why I say that current Bitcoin kernel is not context minimal. It's actually context uh, library for now. But there are some validation functions which don't require context. For example, you can validate a script or script pub key, or basically whether the transaction is valid or not with respect to the script. Not fully validation, but basic part, some part of the transaction, that is script. And also you can uh, there are open PRs, open PRs of mine, which is for block header, whether that block header is valid or not. So that is one of the context free checks, you can say. And also the header is not stable yet. So if you see the Bitcoin kernel, the 30595 PR was just merged into Bitcoin core, and, and we don't have any official release yet. So this is one of the issue, because whether we want had to have a different version of the library, for example the release cycle of the library should be different basically, or it should be included with Bitcoin core. So for example, version 30.1 or 30.2 might have this version of the Bitcoin kernel library, or we want to have a separate version of both, like Bitcoin core and the library. So this is the discussion has been going on. So yeah, the context I've already said. The library provides a built-in static constant kernel context, and I've already said the static uh, context offers only limited functionality. We have the script validation and two three more validation functions. Apart from that, all is the context validation. Basically, you'll need the blockchain. And uh, also we have a SHA-256 implementation in the library, and a random number generator as well. Sec256 static context is also being initialized whenever you validate a function. So for that you will need sec256 library. So that is already being done when you use the API, or basically this library. And error handling is one of the important part, because it's like what happens is you are the library, the core library is in C, and you have different language support. So the problem is that whenever you suppose for example in Rust, what happens is when you create a memory, or basically when you define a function, it stays in its native memory. Okay, not in C memory but in Rust memory. Okay, now C cannot communicate the Rust memory, and Rust cannot communicate with the C memory. So what happens is Rust creates a memory, or basically a function, or basically an object. It stays in the Rust memory. Now when it tries to send that to C, C will just take the value, and C will return whether that script provided by the Rust language is valid or not. Now if C thinks, or if the Bitcoin core validates, and if it's valid, or basically if it's invalid, now it has to return something. Okay, so when it returns, it just returns the reference. Now Rust cannot access that, because Rust is in Rust language and C is in C language, but the memory differs. So Rust cannot access the C memory. So for that, we can't use all the error handlings in C. but instead we can return all the binaries null pointer and 1. So for that reason we can see that functions communicate error handling through the return types. Okay, so we'll just return null pointer 0 or false if there is an error, and if the if verification was successful, we'll just return 1. So that is the issue with different language bindings. So that was the issue. So for that reason C has been used, so that we have a good language support, good language like other language have good support with C. And also we have notifications and logging system, where you can subscribe to this kernel notification and logging, uh, whether that the block has been validated or not, whether that you know whether that script was validated or not. So for example, if there was a script validation, and if we found that the script was not valid, and we don't know the reason, because we are only returning null pointer or 0 or false, so we don't know the reason whether that script was validated or why it was validated. We don't know that. For that reason we have this notifications and logging system, where you can subscribe that, and logging and notification, they'll just supply you the value whether why the script was invalid, or why the transaction was invalid, or why the block was invalid. So for that reason we have used this and logging and notifications, which was already present in Bitcoin core, but for the library we have introduced this, or basically exposed this feature. And pointer, if you are you should, or basically you need to have a bit of pointer knowledge to use this library, because here in this library we have used we have used heavily the pointer. So in memory, so I've already said you why C was used, and C has its own memory and other language bindings has its own memory. So to access the memory is basically the address, and we dereference it to the value of that address contains. So for that the pointer has been used. So if you read, if you see, it says the user is responsible for deallocating the memory owned by pointers returned by functions. So the problem is, I've already said that Rust cannot access the C memory location. Okay, so when C will validate the function, it will initialize some memory. Okay, now Rust cannot deallocate that, because Rust don't have access to that memory, but it can access the function. So there is a function called, every object, or basically every function has a destroy and create method. So you can use create for allocating the memory in C, and destroy to deallocate the memory. So we have to use that carefully. That's the problem. And also uh, function that takes the pointer arguments as well. All functions takes pointer arguments, and cons pointers as well. Cons pointer represent views, and you can't transfer the ownership of the pointers, of the cons pointers. So with due to this complexity with the C library, there was not there was, but there have been a lot of language bindings. So for example, in Rust, you don't have to allocate and deallocate memory, or because Rust is very safe language. Similar goes for Java. Java is garbage collector. It automatically does the deallocation. Python as well, Golang as well. So for that reason, we have different language bindings. Now you can use that language bindings. You don't have to think about whether I need to allocate or deallocate, something like that. You can just use that normally how you use Rust language. But for the basic idea, the I'm just making you understand why, what happens underneath. So the bindings, they are just a wrapper over this library. So this is the C library, and what Rust bindings does is it's a wrapper. The library, whatever it provides, Rust library, Rust bindings or Rust wrapper provides that as well. But the Rust wrapper handles all the allocation, deallocation, so that developers or experimenters, they don't have to think or go through all the allocating and deallocating part. And if you see here, we have an opaque data structure for every for every pieces of code, or basically whatever we need, that has been done through opaque data structure. So we don't have to go through that. That is all the C provides, and we don't have to read that as well. But you can definitely go through all the language bindings. Language bindings uh, has been improved a lot before the PR was merged, and after the PR was merged, all the language bindings has been improved a lot. But still, all the language bindings are in experimental, because we don't have the official library release. It's just been merged into Bitcoin Core, but we actually don't have any official release. So till then, everything is in experimental phase. So let's see what till now what we have in the library. So we have transaction, we have script pub key, we have transaction output, or basically spent outputs, or v out, you can say. We have login, we have all the chain parameters, context options as well, context, and block tree and entry, chain state manager, and all these uh, objects, or basic classes, you can say, or basically data structure. The correct word is actually data structure. We have coin as well, or basically the UTXO, unspent transaction output. So if you are uh, if you run Bitcoin Core, and if you are synced with the node, then you can just use all the context option from here. But the main idea of Bitcoin kernel is not that you have to run a whole Bitcoin Core. The main idea is that you just need the consensus engine, so that it validates all the transaction and blocks and block trees, something like that. So that's the main idea behind Bitcoin kernel. And for now, these are all the data structure that has been provided by the library. And we have lots of functions for using this library. Okay. uh, so for now, let us look into some script validation functions. So yeah, I was talking about how you can create memory in the C address space, that is with this function. So btck transaction create, and you'll just supply the raw transaction data and the transaction of the length. So now this will create a transaction into the address space, and then you can just validate whether the transaction is valid or not. For that, you need to use this one, because you can't create you need to allocate some memory for the transaction, and then you can validate that. So that's the idea behind uh, the creation or basically creation of this method. And you also have transaction copy. For example, from this address space you want to copy the transaction data to another address space, or basically you need to have a copy of the transaction data which you already supplied with the create method. The create will actually return the BTCK transaction object type. Okay, that's important because I've already said you that we have a data structure for every piece, for every pieces of the Bitcoin part. For example, transaction, the data type is BTCK transaction, and similar goes for script pub key, has data type script pub key. But you might have a transaction in integer, or not in integer but in hexadecimal, in bytes, something like that. So you need to convert that bytes, or basically in hexadecimal format, to BTCK transaction type, so that you can use this consensus library. So you can use this function which takes const void pointer to the transaction, or basically the raw transaction, that is basically byte. And then there are lots of functions which you can use. So you don't have to use this library, you can just use the language bindings. Language bindings has good support, or basically good, uh, easy to understand, you know, docs, functions or docs, something like that. So we'll basically look into all the language bindings in the upcoming session, but for now we'll just go through all the C API, and that's the core library. Language bindings is just the wrapper around this library. We also have, if you have created the BTC transaction uh, data structure, then you can see whether that raw transaction had any output, or what was the output format. So for that, we also have a data structure called BTC transaction output, and you will have the output in this format, in BTC transaction output format, or data structure DSA format. And similar goes for transaction input as well. And now that you have the BTCK transaction data structure, you can use that transaction to count all the inputs, get the TX ID, and something like that. And TX ID also has the data structure in BTCK TX ID. And we also have pre-computed transaction. It's like, transaction can be pre-computed, so that we can have all the, you know transaction IDs and something like that, all the data. Now script pub key, I've already said script pub key has a data structure named BTCK script pub key. And you can just go through this header file, if you have some time, or else you can also go through all the language bindings as well. Language bindings should be easy to understand if you want to work with the Bitcoin kernel. And yeah, this is it about the header file, or basically C header. What we can do is we can just go through the how we can use this library. We can just go through that. So for that, we need to uh, clone this Bitcoin kernel club repo, and then I have a issue, or basically a discussion created in the issue tab, and you can just go through all the, like, you know, all the like prerequisites. So you should have Nix installed, and Nix basically provides a good, you know, ready to use a shell kind of thing, or basically development shell. And for that, so that you don't have to clone Bitcoin core and then build the Bitcoin core, so you can just use this one, use this command, and this will just install the Nix. And for setup, you need to clone this Bitcoin kernel club repo and then just type this command. For example, I've already cloned and checked out the master branch, and then you can just type this command, and then yeah, you'll have uh, all the like all the uh, libraries set up. Now you can just, you know, compile, or basically I've created a demo, or basically simple to use library assignment, or basically task, and you can use that to play around with how the library works, or basically the C library works, not the language bindings. We'll see in the upcoming sessions how the C library, or not the C library, but the Rust bindings, the Java bindings, the Go, and the Python one. So first you need to include this header file, because that's the most important part. Similar to how you do in Rust, you use uh, import the crate that you want to use, and in Java as well, import, and in Golang as well. So yeah, similar way in C we need to use this hashtag include and all the header files. And I'm in this demo C file. I've just taken a taproot script, or basically a taproot transaction, and then script pub key. I need to see whether this transaction and this script pub key matches or not, or basically we need to validate this transaction is valid or not with respect to this script pub key. So you can play around with this. You can I'll just show you how you can create, or basically use this library. So first you need to include the data type of the transaction. So I've already said the transaction has data type BTCK transaction, and then you name the data, and then we need to create, or basically create an create or basically allocate a memory in the address. Okay, so for that we need to use this function called transaction create, and then we'll just apply the raw transaction. So if you see here, the raw transaction is in array form, or basically in hexadecimal form. So we'll just use that. We'll just apply transaction, and then we'll supply the size of the transaction. Now if this transaction was valid, then we'll have the transaction PTCK transaction data type. But what if it was not valid? What if we gave some wrong transaction data? Okay, for example, what if I've just deleted this part? Okay, so this is not a valid transaction. Okay, so for that I've already said that whenever there is an invalid in the transaction creation or in object creation, it returns 0, 1, null, or false. So if we see in this BTCK transaction creation, then what it says, it creates a new transaction from the serialized data, or basically a serialized transaction. And what is the parameter it takes? It takes raw transaction, and it takes the length of the transaction. The transaction, if there was successful creation or basically successful allocation of the transaction data in the memory, then it returns the BTC transaction object. Okay, but if there was error in creation of the transaction, it returns null. So if we do we can add here check as well. If it's null, then you just return one, or basically exit the program. So similar way you can just create script pub key. So we'll just apply first the data type, and then because I'm I'm just programming in C, so I can just use this pointer. If you weren't programming in C, then you can just use the non-pointer types, because in C, if we don't use this pointer type, then that means I'm just copying this transaction, or basically copying the address which has already been created in C, because library is already in C. So that is the issue, because copy operation is expensive and move operation is not expensive in C or C++. Again, so I'll just name the data type script pub key. Now we need to allocate some memory. Script pub key. First, we need to allocate the memory. For that, we'll use this function script pub key create. So what is the parameter it takes? It takes script pub key void pointer to script pub key. This is the script, or basically script pub key in hexadecimal form. And we need to provide the size of the script pub key. Now again, we can include here the a check whether that script pub creation was successful or not. If we look into the function, it returns the script pub key, or basically null on error. Yes. If it return null, then we'll just return or basically exit the program. Similar way, there are lots of to-dos which you can complete and play around whether that, like, whether this script or basically transaction validation was successful or not. Yeah, I think this is it for now. If you have any question, you can just yell at me.